This is an experimental new circuit on these two tiny little breadboards with this L298 controller and a 9-volt battery. And here's the armature to the motor, the compass motor, which is removed from, it would normally hang like that, and it's removed from the thing it hangs from, the stand. And I'm just experimenting, and I have some LEDs that I've hooked up to a little battery that I've put on the rotating magnet. And the motor under here is connected to the new circuit. I haven't yet installed it on the bottom of the lower disc because I don't want to ruin my motor yet. And what it does, let's see if it will work. Okay, the battery is powering it on. Now, when the light hits this LDR or this LDR, these are light dependent resistors, or commonly called photoresistors, that will make the motor turn. Now, this LDR up here will make the motor stop and actually go in reverse for a short period of time so that it puts the brakes on. It doesn't really go in reverse, it will just stop in a hurry. So hopefully, to show you what it does, see if we can't get that to work. All right, hopefully what it does, when I shine the light on one of these, the motor will turn. And then when it hits that, let's try again. Doesn't seem to be connecting. When the light hits this photoresistor, this LDR, there we go. That one should work. Let's bring that one down a little. That one should work. So now, let's try it again. That will make the motor turn, and it's not stopping. So why is it not stopping? Let's see. We don't have the wires plugged in. That would probably be the reason. So let's plug in the wires where they go. And let's try again. Turn out the bright light. And let's try it again. So you see, as soon as that LED passes to LDR, it stops. Then it goes again half a turn. Then it goes again 180 degrees, goes again 180 degrees. Now, part of the problem is it gets hung up a little if it doesn't go quite far enough, but I can overcome that. The program it uses Miller's, you know, the famous multitasking replacement for the delay function in Arduino. And this is an Arduino here. So you have 3 LEDs. The red LED is connected to this one. The blue LED is connected to that one. and the green LED is connected to that one. So these two LDRs will be on opposite side of the bottom, and there'll be a light shining like that. And as the motor rotates, as the armature rotates, these will turn it on. And it will rotate 180 degrees and stop until the light hits the other one. I think the problem now is the battery is run down. So it's just on a trial basis. I'm not going to hook it up to the motor yet. But if everything is just right, it will work. And I know with a servo, and you can see that red light blinking. And that's what it's going to do as it goes back and forth between that one and that one as they rotate around. But obviously, I think the battery is run down a little bit. And anyway, I'll show you the Tinkercad version of this circuit. And maybe that will make it a little more clear, because if you see all these wires in here, let me shine the light on there so you can see all those wires a little better. There are 1, 2, 3, 4, 5, 6 resistors. The LEDs have 220 ohm resistors, and the LDRs have 10K resistors, I believe. And or 1K resistors. I think they're 10K resistors. And it's pretty simple setup. The wires are a little bit crossed, obviously, because I should have put the LDRs on this side and the LEDs on this side, since all the Arduino digital pins are on this side and all the Arduino analog pins are on this side. But what I have is I have the breadboard set up, so I have the power running to like a power rail here. One of the 5 holes in this black breadboard has power, so all 5 holes have power. And then I have the ground running to 2 separate on the same row up here, so that you have 10 rows of ground. And then the 9 volts goes into the VCC, and the VCC is also connected to the L298N, so that the ground is also connected to the L298N. So there's no need to have 2 ground wires to the L298N by powering it through the VCC. So let me show you the picture of Tinkercad. The 220 ohm resistors and the LEDs on top, and the 10K resistors and the LDRs on the bottom. There is no L298 because Tinkercad doesn't have it. And in reality, I'm using an Arduino Nano. So here's the code. So just so you get a little idea of it, it uses kind of a machine state or state machine, and uses a switch and a case statement with 2 states for the analog read part of the LDR sensor. So thanks for watching. Like, subscribe, and rumble.